Hi there, I have an integral problem for you, and let's see how we can solve it. So I have x to the n over this thing. The denominator looks like e to the x expansion. It's not, it has nothing to do with it, but this can actually give us a hint because if I take derivative of e to the x, it will be same thing. So I can call this expression, this denominator part, 1 over 1 plus x plus, this is just x squared over 2 factorial plus up to x to the n over n factorial. So let's call this thing a function. Okay, let's say this is f of, so it depends on the n and also x. And now if I differentiate this thing, I will have, so this will shift, so I have 1 plus, this will be just 2 times this thing, so it will, or I can just do it easily on the general term. So this n will come before, so it will be n over n factorial, and I can say that n factorial is just n times n minus 1 factorial. So this will be x to the n minus 1 over n minus 1 factorial. So this will give me all terms except the last term. This is exactly same with fnx. It's almost same as fnx. So I can say that if I take difference of these two, fnx minus fn prime x is going to be equal to x to the n over n factorial. Why did I do this? Because I need x to the n on this part. So I can rewrite my integral and say, so my integral is going to be, I have x to the n, which is n factorial times this thing, n factorial times fnx minus fn prime x. This is just derivative. And at the denominator, I have fnx. And I also have dx. So I can just separate this integral. So I will have this thing, which is n factorial, and it will be minus n factorial times fn prime x over fnx. And I can also separate these integrals. So this n factorial is just a constant with respect to x. So I can just separate both of these integrals. So let's say this is n factorial dx, and this is, I have minus this dx. And as I said, this is just a constant, so this is just n factorial times x. So I have 1 here, and for this part, this will be minus n factorial, and I know that this is ln of fnx. I have derivative, and at the denominator, I have function itself. So this is ln of fnx. So this is my answer. Let's rewrite what was fnx and finish the problem. I have n factorial times x minus n factorial times ln of what was fnx. It was 1 plus x plus up to x to the n over n factorial, and that's my answer.